Hi guys, now this question is about empirical and molecular formulae, and it says that an organic compound X, which contains carbon, hydrogen and oxygen only, has a molecular mass of 85. When 0.43 grams of X is burned in excess of oxygen, 1.1 grams of carbon dioxide and 0.45 grams of water are formed. And we need to find the empirical and the molecular formulae of this compound X. Okay, so let's write down in an equation form as to what we are given. So X is made up of carbon, some amount of carbon, hydrogen and oxygen. We don't know that. Obviously, that's the aim of this question. And this X is reacting with excess of oxygen to give us some amount of water and carbon dioxide. And we're given the masses. Okay, so what I'm going to do is use the empirical formula method to work out the moles of each of the species over here, and let's go ahead and draw a table out. Okay, so we're given that X and O2 are reacting and we are forming water and carbon dioxide. So with that we are given the masses. Okay, so we're given that 0.43 grams of X is burnt in excess of oxygen. We can work that out, and water is 1.1 and 0.45. Oops, no, that's the other way around, sorry. That should be 0.45 grams and 1.10 grams. So we can work out the oxygen by simply adding the water and carbon dioxide and then taking it away from the mass of X. Okay, so 0.43. And that will give me a mass of 1.12 grams. Okay, so let's now work out the number of moles. Okay, so number of moles is mass divided by the molecular mass, mR. Obviously we don't know what the molecular mass, well actually no we do. We are given that the molecular mass of X is 85 and oxygen is 32, water is 18 and carbon dioxide is 44. So the number of moles of each of the compounds are going to be 5.05 times 10 to the power of minus 3, and get a 0.035 for this, 0.025, and the same for carbon dioxide. So now looking at the simplest ratio, the smallest number is the number of moles of X. So if you divide everything by that number, we're going to get 6.9 for oxygen, so we can roughly round to 7, 4.9, so 5, and 4.9 for carbon dioxide as well. So we've got these numbers. Now these numbers are representative of the numbers in front of our equation. Okay, so we're going to have 1 mole of X reacting with 7 moles of O2 to form 5 moles of H2O along with 5 moles of carbon dioxide. So now based on this we can work out what the formula of compound X will be. So carbon, hydrogen and oxygen. Now if you look at the amount of carbon on the right hand side, we've got 5 carbons here, so that must be 5. Okay, that's the only amount of carbons there. Now with respect to hydrogen, we know that there are 10 hydrogen atoms over here, and therefore there must be a 10 over here. Okay, and with respect to oxygen, we know we have 5 oxygens over here and 10 over here. Okay, so that makes 15 oxygens, and we already have 14 oxygens over here, so therefore there must be just 1 oxygen atom in our compound X. So because this is the simplest ratio of all the atoms, this is our empirical formula. Now let's just check if the empirical formula is any different to the molecular formula. So the molecular mass of this very compound is going to be, well, let's work this out. So that will be 5 times 12 plus 10 plus 16. And that gives me 86. Oh, okay. Well, I think technically, therefore, in the question, it should say MR of 86, okay, not 85. It will hardly make any difference in our calculations in the table though, but I feel like that could be a typo. Okay, so MR is 86, and well, this is therefore our molecular formula as well, because there is no difference in the molecular mass of empirical formula, which is C5H10O, and the molecular formula. So this is our molecular formula as well as the empirical formula. Okay, so this is basically one answer. All right, so I hope that helps. Now, let's have a look at another question, which basically might look slightly different, but it is perhaps slightly easier than the one that we've just done. So if you'd like to pause the video and have a go at it, please feel free, and come back whenever you're ready. Okay, so if you have had a go at it, let's just quickly discuss the solution. And for this, I think I'm going to talk you through again in a very similar way, where you basically start by drawing a table. Now, this question is pretty good, okay, because it says you've been given different elements, zinc, hydrogen, nitrogen, and oxygen, and not only do we have to work out the empirical formula of A, we need to work out the actual molecular formula of A showing the water of crystallization. Okay, so I'm trying to kill two birds with one stone over here. I'm covering water of crystallization as well as empirical formula in one question. And this is a question from the June 2022 paper, paper 1, which is the breadth in chemistry. And let's go ahead and try it out. Okay, so we've got zinc, hydrogen, nitrogen, and oxygen. The percentages are 21.99, 4.04, 9.41, and 64.56. The AR values in this case of each element is 65.4, 1, 14.0, and 16. Okay, so the number of moles are really simple. I end up getting 0.336. Okay, so remember, you do not have to worry about the fact that it's a percentage. You just simply do 21.99 over 65.4. Okay, so likewise for the rest of them, I am gonna have these numbers. Okay, so the smallest one of them is the number of moles of zinc, and therefore dividing everything by that number, I will get 1, 12, 2, and 12. Okay, so when it comes to empirical formula, it doesn't matter the order in which you write down the atoms, and the formula just will be zinc, that looks like a 2, Zn, H12, N2, O12. Now, having said this, it doesn't quite give us the molecular structure of the compound. Okay, so it just basically tells you the simplest ratio. Okay, now the next part of the question says write down the formula showing the water of crystallization. So I know that it's got to have some amount of H2O. Okay, and we'll figure that out in a second, but let's figure out what else is there, because there's a huge amount of oxygen atoms. Okay, so you've got zinc, nitrogen, and oxygen, and because it's a salt, okay, it's given to us, it's a salt, it's meant to therefore either, well, in this case, contain nitrate ions. Okay, so nitrate ions are NO3 negative ions, and of course it contains zinc, so that will be Zn2 plus ions. Okay, so the formula of zinc nitrate just on its own is ZnNO3 2. Now that basically agrees with our empirical formula because we need 2 nitrogens and 1 zinc atom. Okay, so if we've got that sorted, let's think about oxygens now. So we've got 6 oxygens over here in this case, but altogether there are 12. Now, of course we have got the water molecule, so that means that there must be 6 water molecules, okay, because that adds up to a 12 for oxygen, okay, and it also adds up for a 12 of hydrogen atoms. Okay, so this is it. So our formula of the hydrated salt will be ZnNO3 with a 2, okay, and a dot in between to represent that it's water of crystallization. Okay, so hopefully this has helped you guys. Questions like this do come up in the exam, so please practice such questions and let me know in the comments below how you get on. Thank you so much.